Okay, so RT60 is like a measurement of reverb. It's kind of represented like this. So if you ever did like physics or maths, you might see that the numbers are a little bit dropped. R stands for reverb, T stands for time. If you just kind of ignore the 60 and think of it as reverb time, it becomes a lot easier. It's sort of like, you know, if that's a higher volume, that's more reverb. If it's a smaller value, that's less reverb. The unit for RT60 is going to be seconds or sometimes milliseconds, but generally is going to be a measurement of seconds. So if you ever used a reverb plugin, it will have the reverb time represented as seconds. What RT60 is then, is how long it's taken for a sound in an environment to drop by 60 dB. That's why we get the 60 decibel thing. So if we imagine me talking right now is, I don't know, 80 dB at a push. And we want to drop that 60 dB to 20 decibels, which is pretty quiet as far as someone talking. We put time along the x-axis. Time in seconds. And that's our dB drop, so minus 60 decibels. So from there to there, that's basically how long it takes for us to reduce that amount. So for this classroom exam, it's probably going to be about 0.5 seconds. It's not very long at all. In a cathedral, it's probably going to be about 4 or 5 seconds. So we can see that that time is obviously going to differ depending on where we are. Reverb is really just how sound decays in an environment. It's nothing to do it's not like a new sound, it's just literally how volume behaves in a certain room. So yeah, that's kind of what we're looking at, is this time. And the bigger that time is, the more reverb there is. There's also an equation for it, so you don't really have to actually measure the time. You can work it out using the volume of the room and stuff. So RT60 equals volume, or the size of a room or a building, divided by sound absorption. So we could have a cathedral that's obviously a big volume, but if that cathedral's made of, you know, rock wool or wood or kind of cotton wool, probably not going to be very reverby, even though it's quite big. Likewise, we could have a really small room like this classroom, but if this classroom is made of metal or tin or something, it's going to be pretty reverby. The more volume we have, the more reverb we have, the more sound absorption we have, the less reverb we've got. So it's kind of a balance of the two. That's it, pretty much. Make sense?
Yeah.
Yeah. Cool. Smash.